All right, good afternoon, everybody. Welcome back from lunch. I hope it was good. I didn't join you. I was busy prepping for this, and yeah, so I hope it was awesome. But I want to start out with a question to everyone. Who here has tried one of Apple's example ML models, like through Turing Create or CoreML? Okay, a couple people. And are any of you actually building apps with CoreML included? One, two. That's awesome. I don't know if I'll talk a lot to you, but the rest of you, I think there's plenty to learn from this discussion here. So I'm Luke MacFarlan. I'm from Skafos. I'm here to share more about including ML in iOS applications today. So here's the talk outline. We're going to talk about why ML for mobile. For some, that might be self-evident. We're going to talk about an example app that we have for you, how we architected that solution, training and deploying a model with Apple's Turing Create framework, and then loading and reloading a model with Skafos and why you might do that. Then we'll wrap up with some Q&A. So why machine learning? I think you all have probably seen, just like we have, the trends that are emerging in the mobile marketplace, and that we're seeing users that expect apps to be smarter. Obviously, we have Siri and Alexa here. You may already know they're powered by machine learning, more specifically sound classifiers and natural language processing. But this is the first of a few things that we know that our customers are expecting, or our users. They're also expecting things to be more personal, but less creepy, which is kind of a knife's edge to walk, right? What you see here is, I think this is Starbucks mobile recommendation, or mobile order and pay app that included some recommendations in it, which I was privileged to be part of rolling out a number of years ago. It was an incredible learning experience, actually. So recommenders come in different types and flavors as well. Sometimes you have items like this, like when you're browsing through Amazon. And in this case, sometimes you have items that pair well with what you've already dropped into your account or into your cart. So they look different. The other thing that users we're finding are looking for out of their mobile experiences are things that are useful in whole new ways. So this is Edit. It's a customer of Skafos's. It's really interesting to us because they allow you to try on aesthetic surgery procedures. A la, if I want a rhinoplasty, I might want to see what that looks like, or a lip lift, or an eyebrow lift. I don't even know if I'm using the right terms because I'm so not exactly the market for this. But there's a lot of friction in this buying process, right? You have to get over personal stigma, social stigma, to book an appointment at a local plastic surgeon after maybe reading reviews for a long time. What the editor allows for is a whole kind of spin on that business model where they are able to acquire customers who are able to try on procedures in a meaningful and realistic way on their own face, and then be recommended a follow-up appointment with a physician. So this model uses ML in the form of, and computer vision in the form of landing facial landmarks all over someone's face when they take a picture of themselves. And then those landmarks are utilized to actually manipulate the face in a realistic way. So there's a couple models that are actually deployed into this. Again, an example of where a user might find a whole new useful way for using a mobile application. So those are more complex examples. How about one that doesn't involve a multi-billion, multinational corporation like Apple, Amazon, Starbucks, or one that is a little less complex than manipulating people's faces?
Music going on.
Oh, well, I thought it was gonna stay that way. It was good for me. Yeah, well, that's good then, right? I'll just keep going, and they can deal with it. Oh, watch this. All right, so we put together a mobile app here. At Skafos, we create example apps that use ML models to solve real-world problems. A little bit more meaningful than, is this a cat, or is this a dog, or is this a hot dog, or not the hot dog, right? So this example right here is Boot Finder. You can actually download it if you like while I talk about it and where we review it here. It's up in the App Store, but it's also open source. The goal for this application is to let users of this application to use a camera to find and purchase an item with just a picture. Now the context is a little different than Google Lens, which would normally allow you to take a picture of your friend's shoes, and no matter what retailer actually has those shoes, you'd be sent off to that retailer, right? So Boot Finder's different in the sense that if you're Nordstrom or Zappos, and you want to create a personal experience where someone can take a picture in their personal environment and use that image to browse through the inventory or search the inventory, this allows that type of thing. So you imagine that this just sits on front of something like Zappos or Nordstrom. You take a picture of a boot, and you will find the most similar boot to the boot that you've seen in the real world. Not the exact boot necessarily, unless that retailer happens to sell it, but you're keeping a user in your ecosystem, right, as opposed to giving them the perfect solution. So I think it's really important to call that out. I think that's it I want to cover here. So let me demo that for you real quick. It's not super complicated. Then we'll talk about how we build something like that. All right, so we have the Boot Finder, fairly simple app. We're going to go ahead and open it up and say Find Boots. And we're given two ways of searching for boots. One is we're able to just go ahead and take a picture. I don't have a lady's boot up here. Megan, my friend in the audience, you're not wearing boots today, are you? No, that's too bad. So I'm going to use the second option, which allows me, we built in a couple images here so that we could search through the inventory that we have represented in this app. I think there's some Doc Martens and a Hunter ladies boot. So let's go ahead and try this one. Let's pretend I took this picture of someone's boot that they were wearing. And pretty quickly you see 5,786 similar boots are found and ranked. Okay, so what's happened here? What's actually happened here is the entire inventory that the retailer has available in this category, women's boots, has been compared to the image that we just fed the model, and ranked in most similar to least similar. So there's infinite scroll here. We could go all the way down to something that doesn't look, anything like one of the boots that we're talking about. But this is essentially how the similarity function works. So if we do find something that we like that is similar enough, we can go ahead and just click buy. That brings us to Zappos in this case, because that's who we use to actually build out this example app. Okay, so how do we construct an app like Boot Finder? I think it's really important right now to say that you can do this. I don't mean that in a disparaging way. I mean that the tooling is out there for people to play around with ML more than they think it is and to come up with POCs. Apple sunk a couple $100 million into Turi Create, an open source Python framework, and pulled them on board. And Turi Create's actually, for everything I understand, powering their new Create ML application that's going to be in the next version of Xcode and Mac OS. So you do not need to master ML, in my opinion, this is my opinion, in order to create an ML-powered prototype. And that's really important, I think, as we walk forward. So start small. That would be the first thing that we're going to talk about here. And don't boil the ocean. These can be features within an app, or they can be entire apps themselves. So what do we need? We need a problem that is suitably solved with ML. That may go without saying, but you probably shouldn't use ML to solve a problem that it's not good at solving. You need your iOS app. You developers know this part. This is the part you know. You need a data source in order to train a machine learning model, and then you need a way to tie it together. And so for the sake of this conversation, for this application, we're definitely living within the Apple ecosystem. We're living within Turi Create, Core ML, which is designed to run in iOS. And we're talking about building the app using those frameworks. So why Boot Finder? I talked a little bit about it. This is a retail company use case. This is a potential employer or a client of yours, and they want to do image-based search, but they don't want to send people out of their ecosystem. If something is not offered by them, you want to keep them inside. It creates a new customer acquisition channel, that's marketing speak, and a personalized shopping experience. These are things that seem to resonate a lot with people who are talking about building these experiences nowadays. And then I've already talked about that they find similar products from within the existing brand. You need a user experience, a basic app, or we can do an embedded feature. For the sake of this discussion and the example, we just very simply wanted to take a picture, feed it through a model, get the most similar boots, and then allow a customer to buy them. So we kept it super simple, and we'd always recommend that you all do that as well as you explore using these technologies. So here's the workflow. If you've seen an example from Worldwide Developer Conference, one of the videos, or all the stuff that's all over Medium nowadays, whether it's cats, dogs, or something more complex, it follows a workflow that looks a little bit like this. You have your app up top, and then down at the bottom you get all this attention around taking an input data of some kind, whether it's cats, dogs, or in our case, women's boots off of Zappos. You feed it through a model framework and train it, and then you get an artifact that's output. In this case, it's a core ML model. You drag that core ML model into Xcode, where you're given a whole lot of extra support by Apple. Meaning you can just drag in your artifact, and they do a lot of the work for you after that. And then you ship that whole app bundle through the App Store. So what does that look like specifically? In the case of Boot Finder, at the bottom you'll see our GitHub repository where you can go ahead and download a larger chunk, or the whole portion of this code. But the salient point that I wanted to call out here, which flies somewhat in the face of our good colleagues' Swift for TensorFlow talk yesterday, is that the whole portion of data ingestion and model creation is 2 lines of code. They're up top right there. That's it, right? And that's why I say if you want to POC or prototype this stuff, organizing your data is probably more important than knowing all of the intricacies of what exactly is happening within that ML model. They've abstracted it to a task. It's image similarity, right? And then out the bottom of this Python, Python file, you're gonna get an artifact called image similarity ML model. So please, after the talk, feel free to go and grab the rest of this file and download it. It also covers a number of different things like the collection of the data, all the way through uploading of that model somewhere else. But this is the most important part for the sake of the creation of the model. How do we use it in the app? I think I already talked about that once you've imported Core ML and the vision framework in our case, because you're using images from the camera, you essentially have this Boot Finder class. And when you drag in that image similarity artifact from the previous slide, this image similarity ML model at the bottom, Apple gives you everything that you see below that. It's really, really quite fantastic how much work they've done to make it easy for you to build models and incorporate in an app. At that point, when you feed an image into this model or into this section of the code, you're going to get, as an output, a ranked order of images similar to boots. Well, you're not actually going to get that. You're going to get outputs from the model that are basically how similar is this image from the target image, to which you can resort according to the most similar or least similar, depending what your use case is. So that's it. That's really how you get an ML model into your app. But there's a problem for our use case. The problem for our use case resides in the fact that, well, actually, I'm going to give you guys a question to maybe answer that. You've got my use case. I'm Zappos, and I've got a category of ladies' boots, and I want to provide this model that runs on someone's phone and allow them to take a picture of someone's boot that they find on the street. And we've talked about everything so far. Why might there be a problem? There's a clue on the slide here. Yep.
Your inventory may change.
Boom, that's it. So if on the bottom left, the input data, your inventory changes, the model needs to change, the artifact needs to change, and ostensibly in this workflow, the app bundle needs to be changed, and then you need to reship it through the App Store. That's problematic for this use case, but more broadly speaking, for a lot of ML use cases. The data changes, the models change, and therefore how we use them, if we're using them on the phone, like in this case, we need to find a solution here. So Skafos has a solution. This is where I basically talk about the fact that this allows us to decouple the app workflow from the data science workflow or from the machine learning engineering workflow. And we do that through our Skafos Swift framework, which you actually put into your app and release to the App Store, and through our Skafos push service, and through our ability to upload even directly from Python training environment into our infrastructure. I could also point out there are other solutions. I just happen to be partial to ours. So it's important to note that this is the crux of machine learning, generally speaking, writ large, that the data is going to change in some window of time, which means your model is going to change, which means you have a cyclical process that is probably out of sync with your app development process. And so whether you solve it through on-device machine learning and something like Skafos, or you end up leaving the models resident running in a cloud environment, you have to consider this problem set, right? All right, so moving forward, let's talk about how you would use Skafos like we do in Boot Finder, and we'll show you how you integrate it with our Python SDK. It's pretty simple. At the end of that Python file, you're going to see, at the beginning, you're going to see import Skafos, and at the end, you're going to see that you can essentially call upload version, where you can throw the artifact that comes out of Turi Create up into our infrastructure, where you'll be able to pull it down through the framework. So how do we handle it on the app development side? We use the Swift framework. And again, here it's import Skafos. You've seen the part where you have boot finder and image similarity, but here under reload model, we have Skafos load. And then we talk about an asset called image similarity, which is how you pull down the next version of the model if there's a diff. So let me show you how you tie it all together on our dashboard real quick. All right, so this is the Boot Finder app and the image similarity model within this app. You see that we have two environments, a production environment with a device count in it, and a dev environment. And then you see all the different model. You see my boss, Michael, who's on Drift. And then you see all the versions that we've saved into our infrastructure, either manually or through that Python SDK. And if we want to deploy the next version of this model, we can do it manually here, or we can do it through that Python SDK programmatically. For the sake of this demo, I'll just show you real quick. We click deploy on that version, we select which environment we want to go to, and then we confirm and deploy it. Now, our example app includes something that if you've already downloaded, there's an update model button on the bottom right. I think it goes, it's worth mentioning, that's not something that we would ever typically want people to be aware of, not users, right? So you as a developer can decide when you want to call for updates on this model. You could do it on app load, you could do it on a certain view loading, or whenever. You could even potentially do it using the push notification service and have it happen overnight so that when they open up the app the next morning, it's brand new. The model is brand new. Okay, so let's wrap up. We talked about a problem to be solved with ML. We've talked about how you'd incorporate it into your iOS app. We've talked about the data source a little bit that we use, which is Zappos. We talked about creating a machine learning model. There's a lot more information in the actual open source code that we're publishing to you. We talked about a way to tie it all together. So this is one example. I really encourage you to explore Turi Create, Core ML, and even Create ML as it comes out of beta. It's kind of tough to deal with right now. To see how accessible ML is for the problems that you face as developers. I think it shouldn't scare you away. There will be times when these models are no longer sufficient for you after POCs or after running out certain features. But I think at that point, you're really looking at the case has been proven, and maybe at that point you need to bring in an ML engineer and replace or tweak Turi Create. There's a lot of work that can be done just with data before you get to that point. So I hope I've encouraged you just a little bit to apply ML to real-world problems. Feel free to come talk to us after this conversation. My colleague Ian is here. Many of you have probably already talked to him. And we're busy providing solutions, tools, and examples like this, as well as content to developers who are trying to develop machine learning solutions using Apple's Turi Create Core ML frameworks, as well as others that are being published and pushed out as well. So thank you for your time.